I'm going to build the eccentric next. The eccentric is the part that operates the valve. I'm going to build it out of this piece of 3/4 inch brass. I think it's brass 360, but it might be bronze. I don't know. Either one I'm sure will work. The eccentric is 3/4 inch, and the piece is 3/4 inch in diameter, and the eccentric itself is 1/2 inch in diameter off to the side, like this. There, that's a perfectly drawn, laid out eccentric. And then of course it'll have a 3/16 inch ringed hole in it through the middle of the workpiece for the main shaft. The eccentric is reading off the drawing here, trying to do that sideways, is 0.31 inches thick with, well, the workpiece is going to be 0.31 inches thick. The eccentric itself is only going to be 0.060 inches thick. So I'll chuck it up. The plan is to face this workpiece off. I notice it's got a kind of a banged up place right there, so I'm going to have to take off probably 50 thousandths. Face the workpiece off and then drill it and ream it 0.1875 inches. I've got my towel down there to collect the bronze, I guess you can't see it, or brass or whatever it is, shavings. Keep them off the ways so I don't have to clean them up because they'll be little tiny things. That looks good. Now I'll set up to drill this one size under 3/16 and then ream it 3/16. I'm going to center drill it, step drill it 3/32, drill it with a number 14, which is 0.182. That'll get me closer to the 0.1875 final dimension of the reamer than will an 11/64, which is .172. So this will get me quite a bit closer. Even at 2000 RPM, which I was turning just now, it's not possible to, that's not fast enough for the .182 number 14 drill bit. That's only going to be about 90 some odd SFM, but that's as fast as I can turn it. In case you wanted to know, I just step drilled it. I just center drilled it. I guess I should have had the camera positioned correctly. I'll turn the spindle at 2000 RPM, but with this number 14 drill bit, which is 0.182 inches in diameter, that's still only 95 SFM. Which is pretty slow for brass, I believe. I know you cut brass pretty fast, like 300 SFM or so. So we'll see how this works out. Using any lubricant. You see some coming off that drill bit, it looks like. No, coming off this acid brush. I didn't mean to use lubricant. I'll change acid brush till I find one that isn't wet with lubricant. Found a new one. Now we're going to step it up to this number 14 bit. Chips coming out both sides, that's nice. Now we'll ream it. Well, the finish looks good from what I can see from here. And as you can see, I hope, see if I can zoom in without losing focus. It took very little off the bore. Took very little off the bore. That may be good. The least, the smaller amount you can ream, the better, I think. Since we're finished with the 3-jaw, I'll go ahead and take a look at this baby. Notice chuck key comes out, but if I don't have my hand on the chuck key, it's because it's laying on somewhere on its home up here. Oh yeah, finish looks real good. I'm really happy with that. Now I'll stick it in the 4-jaw and we'll go about turning the eccentric. I'm about to turn the eccentric. First I need to center this workpiece in the 4-jaw chuck. To do that it's an easy process, but if you don't know how to do it, go out to the internet and download some instructions. I downloaded Little Machine Shop's instructions. They're great. They work for me, and that's the way I do it. Another thing you're going to need to center a workpiece in a 4-jaw are 2 chuck keys. Now you could have 2 chuck keys like this, but that's really cumbersome. What you need is 2 chuck keys, 2 short ones, like this. Like those? They're not available in stores. I made these. But anyway, you need 2 chuck keys to do this. So get 2 chuck keys, get Little Machine Shop's instructions, and you'll be able to center a workpiece in a 4-jaw. After I get it centered, I'll offset it by the amount necessary to turn the eccentric. But that's after I get it centered. Here we are. It's, by my reading, a little less than 1/1000ths out, and that's as close as I'm going to be able to get it on that unfinished brass surface. So I'm calling that good. Now I'll have to offset it to turn the 1/2-inch diameter eccentric. This is my second shot at turning the eccentric correctly. I didn't understand a part of Tolley's most excellent drawings. I think I understand it now. I've reset the piece, the workpiece, after chopping off what I'd screwed up, or turning off what I'd screwed up. And now we're going to give it another try. What we're going to do is turn an inner circle that's tangent to the outside circumference of the workpiece, tangent to it right about here, and that's a 1/2 inch in diameter. I think I've got it set up right now. Taking 72 thousandths width of the cut. I don't really know the depth. I didn't calculate it from the drawings. But I'll take it to a depth that makes the inner circle round, no more than that. And that'll be 1/2 inch. My end feed is faster, but I'm comfortable with this. I've done this before, so I'm sticking with it until I learn different, which may be never. Hopefully, one of you guys that knows something that's watching this video, leave a comment about turning this brass, or maybe it's bronze, faster in this type of operation. It's an interrupted cut, of course. As you can see, it's starting to get close to full circle. I think that's almost it. I'm going to back it out and back it out just a little bit and take a look. Let's see. Can you see we have the tiniest bit that we need to cut right there. I'll feed it in by hand, cut that. Bit more to go. Check it. Nope, that looks good. All right, now I'm going to unlock the carriage and feed the tailstock out so that I'm assured that this surface is, I don't want to say it, it's got to be flat, but there's a better way to say it, but I'm going to do it anyway. And it's cutting, so definitely needed to do that. There. I think I can go further. That's about 5/8, so I can take it down a little further. Alright, here we are. I mic'd it before I performed the towards the tailstock cut to level it out. I mic'd it at 5.5015, and then I thought to myself, well, that makes me happy. So I took another thousandths or so and then fed out towards the tailstock, making sure this was flat. And then I realized when I mic'd it again that since it was on a slope like this, I don't know if you can see that angle that I'm trying to create or not, that what I'd really mic'd the first time was the outer rim of this eccentric. And when I brought it out, I chopped her down some more. So I wound up with a 0.4895 diameter on the eccentric. I'm sure that'll work, but live and learn. Next operation will be to part the eccentric from the stop. It's time to part the eccentric from the workpiece. I'm going to part it off at 1/4 of an inch from here to about right here. if you do this, if you build this engine, you need to drill and bore this, or drill and ream this hole deep enough so that you'll have enough room, not only for the eccentric that I just almost completed, but for its spacer. There's a spacer that also goes on the shaft with the eccentric. You'll see me build it later. But drilling and boring that hole deep enough for the eccentric and the spacer is a wise move. I did that, but I screwed the first eccentric up by having my offset wrong. So I'm going to have to drill and ream that hole a little deeper when I go to build the spacer. So I'm going to turn this at 70 RPM and power feed it at 0.00 or 0.00168 inches per revolution. Separating. Cut's gone well. I really like this cutoff tool. There we go. This, I'll have to clean this up right here. Clean that off. Wish I'd have thought to take a skim cut across the surface here on the circumference. I'll probably figure out a way to put this on some kind of spindle or jig, something, and I'll do that. Next is to build the spacer. Why we need that will become clear later on, but essentially the eccentric fits over this offset part, but what holds it on? You have to have a spacer which acts like just a big washer, basically. If you think this is the main shaft and the eccentric is here, then what holds it? What holds the eccentric on? Well, that's what the spacer's for. I'm going to face this workpiece off prior to creating the hole for the main shaft. Now I'm going to center drill it 3/32, step drill it 3/32 seconds, and then drill it with this number 14, which is a 0.182 inch diameter bit, and then ream it 0.1875. Center drill. What to do with the chuck key? There it is. The washer, big thick washer, spacer, needs to be 1875 inches thick or wide. So I will drill it and bore it to oh, I don't know. What would you do? Something easy. I'm going to get well past the chisel point, and I want to, let's see, I think I'll make it, I think I'll just make it about there. Yeah. About there. A little over 1/4 inch. I'm going to be a little smarter this time. I'm going to mark this before I stick it in there. Using the trusty, highly accurate magic marker method. And then I'll just ream to the bottom. This is a Whitman and Barnes Hercules reamer, high-speed steel. It's from a Detroit area machinist estate sale that my dear brother-in-law got for me. I've got to calculate SFM. I'll be back. I'm going to run it at 61.5 SFM. Looks good. Now I'll set up to part it off. Before parting it off, I'm going to do what I should have done to the done with the eccentric. I'm going to skim about 1/4 inch of it. It's got the to make it nice and shiny. It's only going to be 3/16 inch wide. So I'll take just as small a bit as I can. I knew that I had found the surface of this workpiece, and why wasn't it cutting? And I took 2.5 thousandths or 2 thousandths and another 2 thousandths, and it didn't. All it did was kind of, oh, you can see some rub marks in there. Why wasn't it cutting? I wonder. Oh, look. Have you ever done that? Alright, now that the compound is actually bolted down or tightened up, we'll try this again. That's better, except it didn't take quite enough, darn it. That time I didn't back the carriage off, so I could, look at that. Can you see that? Right there. Just the tiniest bit, but I'm going to take it off. I'll slow my feed down. I was turning at .00252. I'm going to slow her down to .00168. Better take them off. Not too fast. Look like now. The whole piece looks like it's got a flat spot that runs the length of it, but that's going to be okay. That's all I'm going to take off. Alright, I'm going to cut this off. Again, I'm turning this 3/4 inch stock at very slow. Of course, I'm not even going to calculate SFM. I'm going to power feed it at 0.00168. Although the previous one, I said I was going to power feed it at 0.00168, but I didn't. I did it at 0.00252. It turned out all right. I'm going to slow down that bit and see if there's a difference in the finish of this cutoff tool. And by the way, I did not sharpen the cutoff tool in between. I did not hone it in between the time I cut the eccentric off and now. I did not hone it on purpose because I don't want a real sharp cutoff tool with this non-ferrous material, be it brass or bronze. I don't want it digging in. If that's never happened to you, good. It's getting pretty close. It's getting pretty close. Well, the slower infeed didn't help the finish on the rear of this thing, but I didn't really think it would. It's a cutting tool. All right, I have the eccentric installed on the main shaft. You can see it spinning around there. Right there, got the pointer right on it. You can see it spinning around. But what would keep the eccentric flange, think piston rod, from just sliding off this thing to the left? Well, the main bearing's there, but that's not going to cut it. What we need is a washer, and that's what we just built. Now you can see that the eccentric flange will fit in that space right there, and this washer will keep it from coming off. Of course, I've got some in and out spacing I've got to do. It needs to be more like that. So I'll move the main bearing over a little bit. So there we go.